Hello and welcome to the first lesson on this new series on data structures and algorithms, where we're going to be exploring 25 of the most important data structures and algorithms that you must know as a programmer in 2024. The first one for the series is binary search, which, as the name suggests, is a searching algorithm. So let's just get into it. Now, to understand how binary search works, we need to take an example. Here, we have a list. This list has two variables, which are left and right, which basically keep a track of the limits of this list. Left is the leftmost element in the list, and right is the index of the rightmost element in the list. So in this case, the value of variable left would be 0, and the value of variable right would be 9. Now, what binary search does is it returns the index of the search term in a sorted list. Your search term is nothing but the target value that you want to search for in this list. And what's extremely important for binary search to work, or what's essential for binary search to work, is that you have a sorted list in ascending or descending order. For this example, the list that we've taken is a sorted list in ascending order. So, binary search relies on finding the value at the middle index of the list. This basically means that we use the left and right variables, which are 0 and 9, which are the first index in the list and the last index in the list. We add them up, so 0 plus 9, and we divide them by 2 and store that value in a variable called mid, which keeps a track of the middle value, or the index value of the middle element in the list. So in this case, 0 plus 9 is 9, divided by 2 is 4.5, and then we take the floor of this value if it's a fraction. So in this case, it's going to be 4. Why do we take the floor? Simply because 4.5 is not an index value in a list. You can't have fractions as an index value in your list. So in this case, our middle index is 4. Now, what we do next is we compare the value at this middle index with our search term, which is our target. So we're going to be checking, is 16, that's the value at the middle index, is that equal to 51, which is our target? Well, not really. 16 is less than 51. So what do we do now? In this case, we need to understand that we're working with a sorted list, and we're working with a sorted list in an ascending order. So if 16 is less than our target, then all values at index value 3, 2, 1, and 0 are always going to be less than 51, since this is a list sorted in ascending order. So what we do is we stop searching on all the elements, or the whole part of the list, towards the left of the middle value, which is the middle value included. So what we do is we ignore either the left or the right half of the list until it finds the element it is looking for, or there are no more elements to iterate through. So in this case, since 16 is less than 51, we know that we really need to ignore the left half of the list. So we simply ignore the left half of the list. And how do we do that? We update the value of our left variable to mid, which was 4 previously, plus 1. So now left equals 5, which is this part of the list, and that is where your new list starts. And your right stays the same, which is 9. Your target obviously remains the same, which is 51. And then you again calculate a new mid value, which is a new mid index. In this case, it's 5 plus 9 divided by 2, which is 7. And the floor of 7 is also going to be obviously 7. So 7 is our new mid value. And we compare the mid value with the search term again. So is 40, which is the value at position mid, is that equal to 51? Well, again, it's not. It's smaller than 51. It's lesser than 51. So what do we do now? Well, you guessed right. We're going to be ignoring all elements to the left of index value 7, because obviously they're going to be less than 51 anyway, so we don't need to search through them. So for this, what we do is again update the value of the left variable of our program. So what we do here is we do left equals mid plus 1, which is going to be 7 plus 1. And now our new list is basically left to right, which is 8 to 9. And our target obviously remains the same. Here again, we find the mid value, which is 8 plus 9 divided by 2, and the floor of 8.5 is going to be 8. So 8 is our new mid value. And then we compare the value stored at mid in our list with our target. So is 51 equal to 51? That absolutely is equal to 51. So we have finally found our element, and what binary search does now is it basically returns the value 8 to the user, which is the index of our target value in the list. Let's take a look at the flow or the process flow of this algorithm. So first we define our target value to be searched for. Once we've defined the target value, we find the middle index of the list after we have our left and right variables, obviously. Next, we check if mid equals target. The value at mid equals the target value. Well, if it is equal, we say that, all right, this value has been found, and we make the program return mid, which is the index of the element in the list that we wanted to search for. Next, if mid is not equal to target, then we check, is mid less than the target? Well, if mid really is less than the target, then we change the value of our leftmost variable or the left limit of our list, which is left equals mid plus 1. Now that basically shortens our list or helps us ignore the left half of the list, and we have a new limit to our list. Now if the mid value is actually greater than the target, then what do? We basically say, all right, if the mid value is greater than the target, then we're going to be ignoring the right part of the list. So for that, we change the right variable, which is right equals mid minus 1, and that's how you ignore the right side of your list. And after either of these steps, you again go through finding the middle value, which is mid, and then compare it with your target until your list has exhausted or you found your value. Awesome. So now that we know the idea behind binary search, let's get on PyCharm or whatever IDE you use for Python and start coding for binary search. So now that we're all on our IDEs, let's just go ahead and code out binary search or implement binary search using the exact example that we saw in the previous part of this video. Here we have our num list defined and our target variable defined. Now what I'm going to do here is simply define a new function, which I'm going to be calling binary search. And this function takes two parameters, which is going to be the list and it's going to be our target. So we're going to be passing the list that we need to look into and the target variable that needs to be searched for in this list. Now, the first thing we do here is define our two variables left and right. So left, which is our leftmost element in the list, is going to be 0 to start with, and right is going to be equal to len of numList minus 1. And why is that? Len of numList here is actually 10 because there are 10 values stored in this list, but the indices start from 0, so that's 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. So in that case, we can't have numList at position 10. That's going to give us an error, right? So that's why len of numList minus 1. So 10 minus 1 would be 9, and therefore right would refer to this element. Next, what we do is we find our mid value. So here I'm going to write mid equals 0 and then start with our loop. Here our loop is going to be while left is less than or equal to right. And why is that so? That's just so that the limits of our list don't overlap and we basically stop executing once we have gone through all elements, found all mid values. You'll see it when it runs. So while left is less than right, the first thing that we do in our loop is find our mid value. Our mid value is going to be the floor division of the summation of left and right. So within parentheses, we write left plus right divided by 2. These two slashes right here signify floor division, right? Just to give you an example, if you haven't done floor division, if I print 9 divided by 2 and run it, what I get is 4.5. But 9 floor divided by 2 gives me 4. That's exactly what we want. So let's uncomment that and go ahead with our binary search. So now that we have the middle index of our list stored right here, we want to start off with our conditions. So the first condition here is going to be if numList at position mid equals our target variable, then we found our variable. So I'm simply going to write print found, and then what we discussed was binary search returns the index of where it found the target variable in the list. So here I'm going to return mid, which is the index where we found the target variable in our list. And that's where our program would stop. Our loop would stop and the program would stop, and we would know where this element really is. Now, what if mid is less than or greater than our target variable? So here I'm going to write elif mid numList at mid is less than the target variable. Then we want to eliminate the left side of the list, right? So to eliminate the left side of our list, what we want to do is simply update the new left index or the new left limit of our list. Since the current mid is 16 and we want to ignore all of these elements, left needs to be the index which is mid plus 1. So that should be index number 5, which in this case holds the value 25. And if left equals index number 5, then the new list has limits from this particular element to the end, because we're not really changing the right element at this point. So in this case, what we do is we write left equals mid plus 1, and we continue our whole loop. Now, in a situation where your numList at mid is actually greater than the target, you would also need a condition to handle that. So to do that, you'd simply write else right equals mid minus 1. And why is that so? So if in this case, let's say we were searching for the number 5 and this is our mid element, and we see that okay, the value at the mid element, which is 16 is actually greater than what we want to search for, then in that case we'd want to ignore all the elements to the right of 16, including 16. So that is all the elements from index 4 through the end of the list. So in that case, what we do is keep the left index as it is and update the right index to a value which is mid, which is 4, minus 1, which would be 3. So our new limit would be from 0 to 3 right here, including all of these elements. And then we'd go ahead, again check while left is still less than right, and calculate mid, and well, go on with our whole loop. This way, either if the element is finally found, we're going to return this element, or else we're simply going to return minus 1. Why is that so? So let's take a look at this. Here I'm going to write if binary search of numList, comma, target returns, well, minus 1, then print element not found. Let me put that in quotes. Else, well, just print whatever is returned by this particular function. So let's just run that. And here it says found. Why does it say found two times? Because we're printing found here. What we could do is simply remove this and run it again. It says found at position 8. Here our target is 51. It is found at position 8, which is 0, 1, 2, 3, 4, 5, 6, 7, and 8. Again, let's test it out with something else. So we took position 5 as another example. So let's take position 5, run it, and it says found at position 1. So that should be 0, 1, and that is correct. Let's just say I type 655 as a value which does not exist in this list, and I run it. It says element not found. So that's pretty much it for this video, and that's pretty much it for binary search. If you have any questions about this video, about binary search, put them down in the comments and I'll do my best to get back to you ASAP. Until then, just have fun and I'll see you in lesson number 2 with another super important data structure and algorithms lesson.